In this video, we're going to be talking about parallel lines. By the end of this video, you should be able to identify parallel lines given their equations and write the equation of a line given a point and a line that is parallel to it. Let's consider the following groups of lines. So here we have four lines that are parallel, and we know that they're parallel because by definition, parallel lines are lines that will never intersect. As we look at these lines, we also want to take a look at their equations and see if we can spot any similarities and differences. And so one of the things that you may notice is that each of these lines has the same slope, which is 3. In parallel lines are lines that contain the same slope. If you're looking at their differences, though, you'll notice that each one has a different y-intercept or a different constant. And so in our definition of parallel lines as well, it's not just lines that have the same slope, but it's also lines that have a different y-intercept. So this is something that we need to consider as we dive into this lesson a little bit further. So just to review, parallel lines are lines that do not intersect. Our symbol for parallel lines is this right here, which just happens to be parallel lines as well. And then the important things to consider or to keep in mind when we're talking about parallel lines is that their equations have the same slope. So these are lines that have the same slope, but they contain a different y-intercept. So their equations are going to represent or are going to show a different y-intercept. So we can tell from an equation if lines are parallel or not by looking at their slopes and their y-intercepts. So let's look at the following equations. If we're going to determine if they're parallel from the equations, we need to first make sure that their equations are in slope-intercept form. So if we're changing the pair of equations for A, this first one, all that I would need to do is add 2 to both sides so that it's in that y equals mx plus b form. And slope-intercept form, remember that the y is by itself. So to get the y by itself here, I add 2, and what we end up with is y equals 2x plus 2. When we're looking at the second equation in this pair, we would need to subtract 2x from both sides to get the y by itself. So as I do that, what we end up with is y equals negative 2x plus 7. These lines are not parallel because if you look at their slopes are different. One has a slope of 2, while the other one has a slope of negative 2, and so they are not parallel, because parallel lines will have the same slope, but a different y-intercept. If we look at the pair for B, again, we're going to change this into slope-intercept form. So for this first one, again, we're getting y by itself. So to get y by itself for this first one, I would just need to subtract the 4 from both sides. What we would have is negative x minus 4 is equal to y. And I can change it so that the y is on the left and have y equals negative x minus 4. That's not a problem. When we look at the next one, we're getting, again, y by itself, so we'd have to start by subtracting the 3x from both sides. What we would have is 3y equal to negative 3x plus 5. And then divide both sides by 3. So everything gets divided by 3. And what we would end up with, I'll write it over here, is y equals negative x plus 5 over 3. And these lines are parallel because they both have a slope of negative 1 and a different y-intercept. One has a y-intercept of negative 4, one has a y-intercept of 5 over 3. So these two would be parallel because they have the same slope, but they have a different y-intercept. The other thing that we need to be able to do is we need to be able to write the equation of a line when we're given a point and we know that it's the line that's parallel. So remember that for parallel lines, the slope of those lines is the same. So for the equation that they give us, this y equals negative 3x minus 2, all that we're going to need to pull from this line is the slope. So what is the slope of a line that's parallel? The line that's parallel has a slope of 3, so our slope of our line is also 3, or negative 3. We do not need the y-intercept from this line because remember our y-intercept is going to be a little bit different. So we're going to write the slope-intercept form of this equation, knowing that it passes through the point 1, 5 and is parallel to the line y equals negative 3x plus 2. Now I've already pulled what we needed from y equals negative 3x minus 2. All that we needed from this line was the slope because it's parallel to the line that we're writing. And we'll have our point. So now that we have the slope and we have the point that we're using, we're going to use the slope-intercept form equation. So y equals mx plus b, and we're going to write our equation. Now notice that we're still missing the y-intercept, and so if you recall from when we were writing slope-intercept form in a prior video, we plugged in the values that we did know and we solved for b. So we know the y, we know a y value is 5, we know our slope is negative 3, we know the x value from our point is 1, and we can use those that bit of information to solve for the y-intercept. 5 equals negative 3 plus b, add 3 on both sides, and get b is equal to 8. So now I know that my y-intercept is 8. We know our y-intercept is 8. We know that our slope is negative 3. And so now I can write the equation, which is y equals negative 3x plus 8. Okay, let's try this again. But this time, instead of solving for the y-intercept, let's use point-slope form and let's rewrite it. So again, we're writing the equation in slope-intercept form for a line that passes through the point 2, 7, or 2, negative 7, and is parallel to the line of y equals 1x minus 2. Now, remember that we're going to need two things here. We're going to need the slope, and we're going to need the y-intercept. So when we're looking for the slope, we're going to recall that when we're looking for the slope of our line, we need to look at the slope of the first line. So what's the slope of the line that it's parallel to? Well, the slope of the line that's parallel to is 1. So that means that my slope for this line is also 1. Now, we do not need anything else from this equation. Remember that we don't need the y-intercept from this one because our y-intercept is going to be different. So now that we have the slope and we know a point, we're going to write this equation in point-slope form, and we're going to solve it or change it into slope-intercept. So y minus y1 equals m times x minus x1. We're going to put in what we know. So I know that m is 1. My x minus x1, my x1 is 2. So minus 2 equals y minus y1, so y minus negative 7, which would change to y plus 7. And then we're going to change it to slope-intercept form. So remember, when we're changing, we distribute the slope. So this becomes just x minus 2, since it's times 1. And then we solve for the y. So I subtract the 7 on both sides, and we get y equals x minus 9. And so there is my equation that's parallel. You can always check the answer. Again, remember that when we're checking, the slope should be the same. So both of these lines have a slope of 1. Their y-intercepts should be different. So this has a y-intercept of negative 2. This has a y-intercept of negative 9. So we know that we're good here. Looking at our last one, we have the line. So we want to write the equation of a line that passes through the point 1, 1 and is parallel to the line that is graphed. So the only thing that we're going to need from this line, again, is the slope, because our line will be parallel to this one, so we know that the only thing that they'll have in common is the slope. So if we're finding the slope here, we find change in y over change in x. So my change in y as I go down is 1, 2, and 3. So we have a change in y of negative 3. My change in x as I go forward is to move forward 1. So I have a change in x of 1. So we have a slope of negative 3. So this line has a slope of negative 3, so that means that the line that I'm graphing will also have a slope of negative 3. And so when we're writing the equation for the line, remember that we can do two things. We can either put it in to point slope form and change it into slope intercept, or we can solve for the b. So I'm going to use point slope form. So I'm going to use my y minus y1 equals m times x minus x1. I'm going to put in what I know. So I know that the slope of my line is going to be negative 3. I know that I have a point at 1, 1, so my x1 is 1. My y1 is also 1. So I have y minus 1 equals negative 3 times x minus 1. And then I know that when I'm changing this into slope-intercept form, I am going to distribute the slope. So it's negative 3x plus 3 is equal to y minus 1. And then I'm going to add 1 to both sides, and I'm going to get y equals negative 3x plus 4. Again, I can check my answer on here just to make sure that I'm good. I know that the slope here was negative 3. I know the y-intercept of this graph is 5. So as long as my equation has the same slope, which they do, and a different y-intercept, which they also do, then I know that we're good. Alright, before watching the next video, please consider how we write an equation of a line given a point and a line that is parallel to it. As usual, please subscribe to the channel so that you get updates as new videos are released.